Imagine planting your feet, placing your hands against a solid brick wall, and pushing with absolutely everything you have. Biologically, a lot is happening here. Your muscles are intensely contracting, your heart is racing, and you are burning through internal energy. After a few minutes, you will feel completely exhausted. Prescott-Joule established a highly specific definition for energy and work. They needed a reliable way to measure how energy moves through the physical world, separated from human feelings. The fatigue you feel when pushing a wall is simply a measure of your internal stamina. It takes energy for your body to keep its muscles tense, but that internal biological cost has no connection to the strict physical definition of work. This diagram shows the two non-negotiable requirements for work: force and displacement. Force is the external push or pull applied to an object. Displacement is the measurable distance it relocates. If the block moves while pushed, these ingredients interact. Simply possessing a strong force and a large displacement doesn't guarantee you are doing a lot of work. How those two elements align with each other dictates the final result. A massive Newtonian force applied in the wrong direction yields absolutely nothing. If your effort doesn't align with the path the object takes, the energy doesn't transfer efficiently. Direction acts as a strict gatekeeper. Pushing straight down on a box that is sliding horizontally forward requires a specific calculation to figure out what helps the movement, rather than just multiplying raw numbers together. This animated equation shows exactly how physicists calculate this interaction. Work equals force times displacement multiplied by the cosine of theta. Theta is simply the angle between the direction you are pulling and the direction the object actually travels. Think of the cosine as a shadow cast by your force. Only the specific fraction of your pull that casts a shadow perfectly parallel to the floor actually counts as work. Any energy you spend pulling upward against gravity is entirely discarded by the equation because the box isn't moving upward. The angle of your effort acts as a ruthless multiplier. If your push is misaligned with the motion, physics heavily discounts the value of your work. You can easily hit zero work in two mundane ways. A weightlifter holding a heavy barbell perfectly still applies massive force, but generates zero displacement. Alternatively, a hockey puck gliding on completely frictionless ice has displacement, but requires zero forward force to keep moving. But the ultimate mathematical paradox of zero work happens every night. The Earth pulls on the moon with billions of tons of force, yet it accomplishes zero work. This schematic explains why. Earth's gravity pulls strictly inward toward the center of our planet. Meanwhile, the moon's instantaneous displacement is completely forward along its orbit. This creates a perfect 90-degree angle between the force and the movement. The cosine of 90 degrees is exactly zero. Because the force is perfectly perpendicular to the motion, the entire equation collapses. In physics, zero work does not mean an absence of extreme physical forces. It simply proves that no energy is being actively pushed or pulled along the exact path of the object's motion. So what happens when work falls into a negative deficit? Imagine riding a bicycle, slamming hard on the brakes, and skidding 10 meters forward. This diagram shows the wheel's forward displacement to the right, while the road surface applies a massive frictional force directly backward to the left. Because the displacement and the stopping force point in perfectly opposite directions, the angle between them is exactly 180 degrees. The cosine of 180 is -1, dragging the entire calculation into negative territory. Negative work actively drains kinetic energy out of an object. Kinetic energy is simply the energy of motion. The road does negative work on the bicycle tires, pulling that motion away until the bike comes to a complete halt. Which brings us right back to pushing that immovable brick wall. You applied force, but the wall's displacement remained firmly at zero. Work is a strict geometric ledger tracking how energy moves from one system to another. It has no sympathy for your muscles and no interest in your effort.